In this lesson, we will look at Unit 3, Section 3.5, Polynomials of the form x squared plus bx plus c. In this lesson, you will learn how to use models and algebraic strategies to multiply binomials. So in the previous lessons, we looked at how to multiply and factor a monomial multiplied by a binomial, which was one term being multiplied to two terms. This time we're going to do an extension and we're going to have two terms multiplied by two terms, which can be a little tricky, but we're going to use similar strategies. And the strategies we're going to use, again, are algebra tiles, the rectangle model, and distributive property. The first model, multiplying binomials using the algebra tiles, looks a little different compared to when we multiplied a monomial by a binomial. However, this method is very similar. So starting with the left, we're going to multiply x plus 2 times x subtract 3. So when you first set up your model with the algebra tiles, you're going to make your t-chart, and on the top you're going to have one expression, and on the side we're going to have the other. It doesn't matter what expression goes where, you can flip-flop them either way. But in this example, I have x subtract 3 on the top and x plus 2 on the side. So you model that first, keep it in mind that the yellow tiles are positive and the red tiles are negative. And then we're going to multiply to get what is inside the t. So if we have an x times an x, so a rod times a rod, that is going to produce a x squared tile. Then we're going to move in. We're going to have the x tile times the negative 1 tile. And that is going to produce negative 1x. And we can do that 3 times. We're going to get the same result. We're going to get 3 negative x's. So that will cover along the top of x subtract 3. Now we're going to move down to the 1's on the left hand side. So we start off with the 1 times the x bar. That's going to leave us with 1x. We're going to move in. Positive 1 times a negative 1 leaves us with negative 1. And we're going to repeat that process again for another 2 more times. And again, we're going to go back to the left hand side and we have one more positive 1 left. And we're going to go positive 1 times x, and that gives us positive x. Positive 1 times negative 1 is negative 1 again, and you will repeat that twice. So once you multiply everything there, it's similar to the distributive property, we end up getting a positive x squared tile, negative 3x, positive 2x, and negative 9. So what I'm going to do, I'm just going to take everything that is underneath that t-chart, and we're going to see what we have. So we have the x squared tile, there's no more to match up with it. And we're just matching up our zero pair. So a positive and a negative x, and again a positive and negative x, and then we have a negative left over since there is not another pair. And we have our 9 negative 1's left there together. So once we have our zero pair, they are eliminated. A positive and a negative is 0. So we are left with x squared tile. We have the negative x tile, and we have the negative 9 1's left. So once the zero pairs are all removed, we are left with our answer, which is x squared subtract x subtract 9. Our next model is the rectangle method. And again, this is the rectangle method, the box method, or the area model. It has 3 different names that it could be recognized by. So very similar to the first method we discussed, we're going to draw a rectangle or a box. And along the top, you're going to put each term of our first bracket. So we're going to have the x and the 2. Along the side, we're going to have each term again, the x and a negative 3. It doesn't matter which expression goes on the top or on the side. They can be switched. It doesn't change our process. It just changes where they're placed. So we're going to start off. X times x is x squared. X times 2 is 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. So you just multiply everything so that you will get 4 spaces all filled out. And once you're done, you're just going to put together your like terms as you can see on the right hand side, starting off with our x and working our way down through x, or start with x squared and working our way down through x and our constant term. So once we do that, we're going to add like terms. So really our like terms are on the diagonal there, 2x and negative 3x. Once we add those together, we're left with a negative x. We only have one constant term there, so we can leave that negative 6 alone. And we only have one variable of x squared, so that stays the same. So once we add our like terms on the diagonal, we have our solution. So it is x squared, subtract x, subtract 6. And our third model is a distributive property. X plus 2 times x subtract 3. Again, you start off with the x in the first bracket, and you're going to multiply it by the binomial. And then we have a positive 2 that is going to be multiplied again by the same binomial of x subtract 3. The x is going to be multiplied into the x, so that gives us x squared. Then the x is going to be multiplied into the negative 3, which leaves us with negative 3x. And the same process happens in our second bracket. So once we are done and we add our like terms, we're left with x squared, subtract x, subtract 6. And in summary, the strategies for multiplying binomials are very similar to the strategies we used when we multiplied a monomial by a binomial. You can use the algebra tile method, the rectangle or box method, and the distributive property.